Hello and welcome back to my channel. So today we are going to solve some problems on derivatives and limits. So let's begin. So the first problem, we have to find the derivative of function of x, that is given as sine of x square and cos of, it is dot here, that means it's multiplying. There are two functions, cos of under root x to the power 4. So we have two functions here, and to derivate it I have used the product rule from the derivatives, so we can define this one as u, and we can name them, and this one as v. So we know that derivative of u times v is u dash v plus v dash u, where dash is the derivative of that particular function. So solving this problem, we first finding the derivative of sine x square, we have cos x square, and then keeping v as it is, times cos to the power 4 under root x, then adding v dash, that is minus sine under root x, sorry, first it will be 4 times cos of under root x, because this 4 will come down, then it will be 4 cos 3 under x multiplied by the inner function. So first we differentiate this because the derivative of x square or x to the power n is nx minus 1. So therefore, considering this as x, all function of x, and that's why we are doing 4 cos 3, so it's x to the power n minus 1. So then coming back, we need to differentiate the cos function, and then it will be multiplied by minus sine of under root x. Then differentiating the under root x part, we have multiplied by x minus 1 by 2 by, it is by 2. And here as well, when we differentiate sine x square, we need to differentiate sine, then we have to differentiate x square as well. So it will be, so just write 2x times cos square x. So therefore the derivative will come out to be 2x cos of x square multiplied by cos 4 under root x minus of 2 cos 3 under root x times sine of under root x times 1 by under root x. So this will be the derivative of this function. Moving on to the next problem, we have to find the derivative of function f of x equals log x to the base e multiplied by another function, that is x to the power 1 by 3 minus 1 by x square. So I can again, using the product rule, I can label this one as u and this one as v, and start to differentiate. So we know that f dash x will be u dash v plus v dash u. So starting to differentiate, first the u part, so we will write differentiation of derivative of log x will be 1 by x, then keeping v part as it is, x1 by 3 minus 1 by x square, then adding v dash, that is 1 by 3x to the power 1 by 3 minus 1, that is minus 2 by 3, and then minus 2 of x minus 3. Yeah, minus 2. Okay, and then multiplying it with log of x. So sorry, it will be plus here. Yeah, so this is the derivative of function of x. Now again, going to the next question, we have to find the derivative of function of x given as sine inverse x by e to the power 4x. Now I can also write it as e to the power minus 4x and multiplied by sine inverse x. So again, we have two functions here. This can be u and this can be v. So let's start to differentiate using the product rule. We have the differentiation, or f dash x. The derivative of e to the power minus 4x will be e minus 4x multiplied by minus 4, and then keeping sine inverse as it is, then adding v differentiation, that is the derivative of sine inverse x is always 1 by under root of 1 minus x square, and then multiplying it with e to the minus 4x. So all in all, the derivative will be minus 4 e to the power minus 4x times sine inverse x plus e minus 4x under root 1 minus x square. So another question, we have to find the derivative of function of x equals x to the power x plus 3, and x is greater than 0, or it is a positive number. Y equals x times x plus 3 to the power x plus 3. So if we apply log, we'll get log of y equals log of x to the power x plus 3, and it's all to the base e. So we know that from logarithmic functions that if we have log x to the power n, and n being any positive real number, we can rewrite it as n times log of x to the base e. So applying the same concept here, we are given that x is greater than 0, that means it's any positive real number. So therefore we can rewrite log of y as x plus 3, because it's a positive real number, times log of x. So once we do that, we can differentiate both sides. So then once we start differentiating, we'll get differentiating with respect to x, so get 1 by y times dy by dx due to the chain rule equals 1 times log of x plus 1 by x times x plus 3. So it is the product rule that I'm applying here, considering this as u and considering this as v. So we know that derivative of u v equals u dash v plus v dash u. So therefore once I do the derivation, we'll get something like this. So now simply I have to write dy by dx equals log of x plus 3 divided by x times y. So this is the derivative of the function x to the power x plus 3. So let's move on to the next problem. We have to find the limit of this function when x approaches infinity, positive infinity. So the function is given as under root of x square plus 2x minus under root of x square minus x. So if I simply substitute infinity in terms of x, in place of x, I get under root of infinity minus under root of infinity again, which is undefined. So therefore, to simplify this equation, I can first begin with labeling them. Let's say I label this one as A and this one as B, right? So now we have got A minus B, right? So our aim is to remove the infinity part from the equation, from the numerator. So let's see how to do that. So we have A plus B. Let's see. So what if I multiply it by A plus B and also divide it by A plus B? So we can see it is 1, it will still be A minus B. So that means A square minus B square whole divided by A plus B gives me the same thing. So let's try doing that, and we get, by doing that we get 2x, so we get 3x in the numerator, and we get x square plus 2x plus we get A plus B in the denominator. So still we have x in the numerator, that means it's still undefined if I apply limits right now. So what I can do is, so I'll try to simplify this more. We can see that x square is common in both these terms. So let's say if I write it as under root of x square 1 plus 2 by x, right? So I'll get the same thing, x square plus 2x. Similarly for the another term, I can rewrite this as x square times 1 minus 1 by x, right? That means x square will come out as x, so therefore I'll get 3x by x times 1 plus 2 by x plus under root of 1 minus 1 by x. So x is cancelled out, so I'm left with 3 and 1 plus 2 by x. So if I apply limit here and x approaches infinity, let's say I'm putting infinity in place of x, so I'll get 1 plus 2 by infinity is 0 and 1 minus 1 by infinity, so these two will be 0, so I'm left with 1 plus 1, so I'm left with 3 by 2. So this is the actual limit of this function when x is approaching positive infinity. So thank you for watching this video. I hope you like this video, and please watch the whole playlist that I made on derivatives as well. So thank you for watching.